Hey folks, so I got a new drawing tablet 10 months ago. I opened the box for it today though. I'm sort of starting on the game design, art design, whatever you call it, part of whatever my project is. I don't know if it's going to be a short game or if I'm going to try to do something a bit more ambitious. Long story short, I'm stepping back away from the programming just a little bit. I still want to spend a few hours every week inching forward on that. But I wanted to sort of, as I'm getting more into the art direction side of things, actually start talking about my code architecture at a bit more of a higher level since the development speed on that's going to slow down. And I got a request from a subscriber to talk about my rendering architecture. Specifically, I was asked to talk a little bit about how I organize my materials and my shaders and all of that. So hopefully I can break that down a little bit. I don't think I'm doing anything new here, but this might be insightful for folks who are just, starting game engine development, or if you're just interested in how maybe someone would organize a system like this. I do want to reiterate that this is specifically for the rendering system. I have a lot of different systems in my engine, and maybe I'll just visualize them a little bit here. So what I have at the very center of everything is my core engine. Now, this is pretty much just a landing spot for everything else. So I have, sort of pointers that I'm storing in that core engine to any of my other systems that I have managing things. So I might have like, my physics manager. I have an animation manager maybe. I actually don't have one of those, but I have a similar. Well, we'll get into it. Maybe a scene. Actually, I call this a scenario, which is sort of like my component tree manager. It contains my scene object hierarchy, all that fun stuff. I have like a debug manager, which handles debug visualizations, switching visualization modes for my rendering widget. I have a couple other ones here. Off the top of my head, process manager. So yeah, what that process manager is doing is that sort of managing all of my tasks. So I pretty much, well, here, let me add, let me start a new diagram here. So I have, what's happening is we have the sim loop, right? So what is managing all of the logic in the entire engine. So what that looks like is, it's pretty much a while loop, but you'll have something like initialization, right? And that gets done once. And then you sort of start this update loop. This is like sort of like a nested state machine. So this is the update loop. And then when that update loop is done running, which it'll do recursively, then we, close scenario. Not necessarily the application. You load in a scenario. So that would happen like in the initialization. So load scenario would be, I have my metadata. So I might have, so a scenario can have multiple scenes. So let me just draw it. Scene 1. Scene 2. Currently, you can only have one active scene at a time, and the multiple scenes don't really actually do anything. But I have all the hooks in there so that if you wanted to toggle scenes on the fly, it would maybe take me like a week or two of actual programming to finish out implementing that. But then every scene has like your scene objects in them, right? So within this scene, I would have, I'm just going to draw little circles for my scene objects. This is also helping me figure out how to use my tablet. So each of these are my scene objects in the scene. They're actually stored in a vector. And then each scene object can be broken down, into, some number of components. I might have like a model component animation on there, through a camera. So, this is like what you'd see in Unity Engine. You have scenes with scene objects with components. It's a pretty standard scene graph way of organizing things. So that's not anything new. The update loop also isn't anything new. So you'd have your, so I have internal engine logic, like, update, and this is not legible. We'll update animations, we'll update physics, and then we'll update scripts. So this is going to be if I define a Python script, because I also have a Python script component that I can attach to a scene object. Then those will all get updated. I have a queue that'll funnel those in and do that in this update loop. What is cool about this is that you have some flexibility. I have sort of a priority system. Once again, like Unity, where you can set your script execution order. But I also have the hooks in to flesh out a system where you can set scripts to run multiple number of times and just provide a bit more of a state machine type of logic to how often your scripts are going to run. So I'm not going to get too into the weeds of how this part is actually implemented, but it's a good time. So maybe in another video. So this is sort of giving an overall sense of the entire engine flow, right? So I sort of have a breakdown. This is more of like a programmatic breakdown of, make a different color. This is sort of my programmatic breakdown of how the actual code itself is laid out. And this is more, application flow kind of diagram. And the part of that I'm going to actually hone in on for the second half of this video is the render. Make that the right color. Render, it's important. Rendering. Render the scene. You update your animations, your physics, you update all your scripts, all your game logic, and then you render every frame. So I do, some stuff is threaded. I don't have animations on their own thread yet. I do plan on pushing them to their own thread. Physics runs on their own thread because that's running PhysX, which does that by default. Thank you, PhysX. And then you have the rendering. So generally serialized. A couple things go off on their own threads. But that's the flow. So anyway, without further ado, let's talk about rendering. So rendering's cool. The basic idea is, now I'm not going to get into the low-level weeds of rendering. I use OpenGL. You can use Vulkan. You can use DirectX. And you could use Metal, but don't. I don't like that Apple tries to make everything exclusive to their own platform. It's not open source friendly and very exclusionary. There's a reason why Apple doesn't have any games on their hardware. So anyway, these are big boys. What I do before I do anything is I take OpenGL and use OpenGL, happy boy, and I wrap it in my API for it. We'll just call it my GL, good GL, my abstraction layer around GL, because GL is very functional. It's not object-oriented in the slightest. Everything's an integer, and it's very unintuitive, especially for someone who hasn't done graphics work before, to understand OpenGL's pipeline. So for anyone who's looking to get into game engine design, my first recommendation is just get stuff drawing. It took me a week to get I use Qt as my main framework. It took me a week to get OpenGL running and rendering a triangle in Qt. And that's because I had to do so much setup initially just to get that first triangle drawing. And like, OpenGL pretty much works by, you take geometry, you have geometry data, and you have shader data. Essentially, that's really it. At the end of the day, you have stuff, and you have a way of coloring in that stuff, and it can be as simple or as complicated as you want it to be, but that's what it comes down to. So this is, you have a VAO, a vertex array object. You don't need to use a VAO. That's for more modern OpenGL, which is an aggregate of VBOs, which are your buffers that actually contain geometric information, points, and maybe metadata associated with those points. And that can be, maybe I have a weight for each vertex that represents how much that's going to impact an animation. Or maybe I have a color associated with each vertex, and I'm just going to use that to color a model. So you can associate any sort of metadata with each vertex. And then you'll have your indices. These are vertices. They are points, but I feel like vertices better communicates the intention. And then you have indices, which actually, if you're going to do things in a way that's even remotely optimized, this just tells you in what order you're going to be drawing your triangles from these vertices. So this prevents you from having to, duplicate vertices. If I have something like this, and I have two triangles, I can give 6 indices that describe the flow of those two triangles. Whereas if I wasn't using indices to render my buffer objects, then I'd have to give 6 points of data. So it saves you having to store extra data. I'm getting a little bit too into the weeds though. Point being, I have abstracted my geometry data out into a mesh class, so I don't even worry about any of this. Once I have it all working, I just put it in a mesh. And then my shader data, I put into shader program classes, which are sort of aggregates. That's an actual running shader. Shaders in OpenGL and DirectX. You have a vertex shader, which sort of sets up the geometry. It's the best way of describing it simply. And then a fragment shader, which handles the per pixel coloring of things. So yeah, so that's my abstraction. I don't want to get too into the details of that. There's a lot of lessons learned in easy ways to organize the data, but I don't want to get too into that. Maybe for another video. I'm already running pretty long. But what I do want to talk about is the sort of higher level application flow. So let's assume I have OpenGL working, or DirectX, whatever my backend is. I have my geometry data getting serialized properly from a file. Maybe I'm loading in an OBJ or an FBX or something. I'm actually using async. I'll write it out to load in model types, and then I'm serializing them into my own binary format to make it faster to read them in after that initial load. So yeah, async's a good tool. It'll save you a lot of development overhead if you're working in C++ for loading in geometry. But you load in your geometry, and then you have to actually draw it. And what I was doing before was something like this. Let me zoom in a little bit since I'm running out of room here. I was doing something like this. I was iterating through my scene. So for each step, that's a little bit too far. A little bit too far. For object in scene, I would say, okay, for component in object, remember these are my scene objects, then I would say, okay, I have a switch statement, component type, I'm using pseudocode here, and now I'm using brackets, so I'm not being consistent. So for each component type, do something. So maybe if I find a model type, so I have maybe a model component is a bunch of different meshes, and then maybe I also have, maybe I check if object has component shader. So if I have a shader component and I have a model component, then draw model. So my rendering loop literally just was iterating through every scene object, through every component in the objects, and then drawing a model if there was a model. Now, what I currently do is sort of an extension, not an extension of it, but it's a little bit, it's a major addition, but not a huge change to the core application logic here, is I actually queue the model for drawing. Model. So what this will do is this will actually throw my model and all the information, the geometry, everything, into a geometry, I guess, rendering class that I have. Now everything, it's separate from my scene hierarchy. I don't have my drawing logic tied into the generation of the required draw commands for each frame. So this is actually, I think this is actually called like create draw commands. So this will create a command which has like a pointer to the geometry data, maybe shader, which shader to use, uniforms to set. That pretty much covers it. Uniforms can be a lot of different kinds of data, but that really that's everything you need to render. And any other miscellaneous GL settings, transparency, that sort of thing. And that's the system. That's ugly to look at, but that's essentially what's going on here, and it works well enough. I implemented not deferred rendering, clustered forward rendering a few months back, and I get 100 plus frames a second with hundreds of lights in the scene and a good amount of geometry. So this is not the bottleneck. This is fairly lightweight compared to the actual rendering part of things, where I'm sure more senior developers than me will get really agitated that I have a double for loop here. It's just sort of one of those things where you get it working, then you get it working fast, and then you get it working pretty. So right now it's just working. If you wanted to actually implement something like this from the get-go, I would say see if you can eliminate these sort of substructures. So one of my plans is to actually, instead of having I have a vector of scene object 1, so 2. People are gonna get mad at me for starting my indexing at 1. And instead of doing a nested sort of thing where then I have like this breaks down into another list of component 1, component 2, component 3. It would be more cache friendly if you every time you created a component through your UI, because I have a sort of UI that is similar to what you'd see in Unreal or Unity for dealing with your scene graph. Instead of actually literally adding that component to an object that represents something in your scene, maybe you have a global list of all model components, for example. And then every frame, instead of having to do, go through every scene object, every component and check if it's a model, then you just iterate through that list of all of the model components in your scene. And that's one for loop, much better than a nested for loop like this. Honestly, it is much faster, but this double for loop isn't that slow for me. This isn't my bottleneck until it becomes a an architectural problem. This is fine for now. It doesn't really touch any other aspects of the engine. It's just sort of that core rendering loop. So it's not like as I add more, I'm going to put myself in a lot of technical debt for doing it this way. But yeah, I mean, I don't know if that's useful. I just ranted and raved for 20 minutes. That's going to be by far my longest video. But hopefully it's somewhat insightful. hopefully it raises some questions. If not, let me know. I can be a bit more directed in my next video. But yeah, now I have like sort of a little virtual whiteboard, so I can do a lot more of this sort of just putzing around, rambling about code I've been working on. Anyway, I don't want to go any much more over 20 minutes than I already have. So thank you, anyone, for if you stuck it out this whole time, then you have the patience of a saint. My hat is off to you. All right, till next time, folks. Bye-bye.